Hey everybody, it's Mr. Mott. Mr. Scott's going to listen in here. You want to say hi, Mr. Scott?
Hello.
All right, we're going to go through the, or I'm going to go through the resources lamplighter review with you to kind of know how we got some of our answers that we did. Okay, so we've got our normal reaction here. You'd always want to check that it's balanced. I think this one already is. So from there, the first question says, write the complete ionic equation. So what I do here is first I want to identify what are the atoms and what are the ions. So magnesium is by itself here, it's alone, and from nuts and bolts we said if it's alone it's an atom. So that's why I wrote down zero charge, because atoms have a zero charge. Then I look at copper, nitrate, aqueous. Now what we want to know about aqueous here, switch to another paper, is that when it says aqueous, what that means is that when I see this aqueous, what I should envision is that I have a beaker and these ions are floating around in that beaker separately. Okay, so I have my copper 2 plus ion, your NO3 minus ion, and another NO3 minus ion. And they're floating around there separately. Okay? Now, as far as how do you know the charge is there, you got to go to your ion chart. So then on the ion chart, we'd go to copper. Okay? So then, a lot of different colors there. Now, so you can see that copper, it can be a +1 or +2. So since we don't know directly, we're going to look for the nitrate. And so if we look on the nitrate here, nitrate is an NO3 minus. And so since there's two of those, you have a total of a -2 charge from your nitrate ions. So that means it has to be copper 2 plus. Okay? So we had to do a little bit of work there to figure out the charges. But the main idea is that when you see that aqueous, you should think about it as it's these ions and they're all separate from each other. So when we go to so what we want to do in our complete ionic equation is to separate these and say, this is really a copper 2 plus ion and 2 NO3 minus ions. The 2 goes in front now because those ions are not attached. Okay? They are separate from each other. So this says how many I have. Similarly, when you go to the MgNO3, the magnesium nitrate, you look on your ion chart, magnesium only forms a +2. And similarly, from the other example, you have your nitrates here as well, and with a 1 minus. Copper is alone, so it's an atom, so I write copper 0. Okay? All right. So then, when we go to our net equation, we want to look for, cancel out any spectator ions, the one that looks exactly the same on both sides of the equation. And so your nitrates are going to be exactly the same on both sides. So we'd cross those out, and your net equation is writing everything but leaving out those spectators, leaving out your nitrate ions. Okay? From there, we're going to look for the oxidation and reduction half reactions. And so what this does is going to help us look at what's happening a little more simply. So we say magnesium goes from magnesium 0 to magnesium 2 plus. Bless you, Mr. Scott.
Thank you.
And then we'd want to, and then similarly, you got your copper goes from 2 plus to 0. Now, in this oxidation reaction, I've added 2 electrons, this half reaction, I've added 2 electrons to the right. Now, magnesium atom is losing negatives to become positive. That's the thing to remember about this. And then we added 2 electrons because if this lost those 2 electrons, we know they're not destroyed. Now they're going to be, we represent them as being on the right-hand side. Another way of thinking about how do we know that the electrons go on this side, you can think about it like the total charge on each side has to be the same. So if you add your 2 negatives and your 2 positives, you get a total of 0. So on the right-hand side, your total charge would be 0, and that matches the 0 charge on the left. Okay. Similarly, we add 2 electrons on the left-hand side of our reduction because your 2 positives and your 2 negatives add up to 0, and 0. We have a total of 0 charge on the right. Something else to think about is that when oxidation happens, reduction happens at the same time. So if magnesium loses 2 electrons, then the copper ion should be gaining those 2 electrons. Okay? Okay. Next page. So now we're looking at trying to find information on our periodic table. So it says identify the element in period 3 that is the most reactive with water. So period 3, we want to remember that periods are going to be your rows. They go left and right on our on the periodic table. Okay. So let me track down one that we can take a look at. And the reason that it's sodium is because sodium is one of those alkaline metals. And in class, we watched a video on the alkaline metals from the Brainiac. And so within period 3, sodium is the alkaline metal, and that's why it is the most reactive. Okay? So here's our periodic table, and then in period 3, sodium, and then the first column here, starting with lithium, is our alkaline metals. Okay. Element in group 2 with the highest ionization energy. Okay? So in group 2, the highest ionization energy. So group 2 would be the second column, and the highest ionization energy would be from the atom that's the smallest. So since your trend is that atomic size increases as you go down, your smallest element in group 2 would be beryllium. So beryllium holds onto its electrons really tightly, and that has to do with the atomic size being smaller. Element in group 3 with the smallest atomic radius. So group 3, smallest atomic radius. Okay. So if it's in group 3, and we'll be a little more specific on the exam here, they're talking about this group, smallest atomic radius would be scandium. We will distinguish between, like, normally we say this is group 1A, 2A, and then across would be 3A. In this case, we just mentioned group 3, so we'll make it more clear on the table. So, all right. Element in period 3 with smallest atomic radius. Again, period 3 would be the row. So as you go across, smallest atomic radius would be argon. Okay. So you go bigger as you go down to the left and smaller as you go up and to the right. Highest metal reactivity in group 2. Okay, that's going to be the one that's furthest down. Okay, so in group 2, starting with beryllium, all the way down to radium. Okay. Period 4, highest non-metal reactivity, bromine. Okay, I would say. So that's in period 4. So period 4, and so highest, according to the trend now, would be bromine. Okay. And so bromine is going to be more electronegative than the elements to its left by our trend. Okay. Then we've got element in period 3 containing the noble gases. Okay, noble gases are on the far right-hand side. So this is period 1, 2, 3. It's going to be argon. Element in period 2 that has to gain 2 valence electrons to be a noble gas. So 2 electrons being noble gas. So in period 2, you're dealing with these elements. And if oxygen gained 2 electrons, it would be like neon. So it would be oxygen. And then lastly, we have groups. Which ones act more similar chemically, I should say, is going to be groups. That's why we call families as well. Okay. Electron configuration for silicon. Okay, so we could use the electron boxes for this. So that would be one way that we can go about this. Or you can use the periodic table. Here's how you do the boxes. So you're going to look up, and then silicon has 14 electrons, if I remember correctly. Yep, because it's atomic number 14. So you would need to put 14 electrons in here. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So for silicon, it'd be 1s2 from here, 2s2, 2 electrons in there, 2p6, 6 electrons here, 3s2, 1, 2, and then we have in the 3p's, you have 2 electrons. And as a check, 2 plus 2 is 4, plus 6 is 10, plus 4 more is 14. That's how we know that we have 14 electrons in there. Your exponents add up. The short form electron configuration for scandium, okay, you can actually go by your periodic table. So here's scandium in the 4th period. So you go to the noble gas that came before it, which is argon, and then you add, so then you go from argon, we're in period 4 now, and then these represent the S's. So you go argon, 4 from the period, S, 2, and then you drop down to the 3D1, okay? The long form electron configuration for nitride, N3- with 10 electrons. So nitrogen normally has 7 electrons. And if it's a 3-, that means it's gained 3 electrons. So it's 1, 2, 3 more. So we'd have 10 total electrons. Now, if you're on your game, we know this is period 1, this is period 2. So you'd go, your 1s2 is filled, 2s2, and then your 2 p's, these are your p's. So 2, p, and then a 6. 1, 2, 3, 4, 5, 6. Okay, that's how we get that answer. All right. I'm going to skip the continental drift questions. That's a little bit about a little review. If you're having trouble with that, you may want to go to the back to TASA and look at your notes or look at the program again. Okay. From the resources quiz that's on here, you've got protons come from the atomic number. Since it's an atom, the electrons are the same. Neutrons, you're going to round your atomic mass, and you're going to subtract. So 27 minus 13 gives us 14. Okay? Now, for the 3+, we want to recognize this only changes the electrons. So if you lose 3 negatives, you get to be 3 positive there. So, and you can also add up your positive parts and your negative parts. Okay? And so positive 13, negative 10 gives you positive 3. Okay? All right. Some different properties of iron. You might have some different ones here, like that it's conductive. Okay? Malleable, hammer into a sheet, make it into a wire, is ductile. Iron can rust and loses electrons there. You could also say it reacts with an acid to form hydrogen, which is a property specific to metals. Okay. You've got your oxidation and reduction again. We want to recognize aluminum is the atom. Here, iron is the atom on the right. There's 2 of them, which is important to notice. And the charge on aluminum from here is 3+. All right, look on your ion chart for that. Since you have 2 aluminums at 3+, you need a total of 6 electrons on the right-hand side. So remember, 2 times 3+ is positive 6, and this is negative 6. Okay? So that's about it for our review. Okay, take a look. Hopefully that helps. This should be 03 there. Hopefully that helps. And then email your teacher or come see us with any questions. Thanks very much.